Hey guys, how's it going? Fred here at Math and Engineering, and we're going to look at just two more antiderivative problems. We're not going to do too many problems in this section, just because we're going to do so much of this when we do integrals in this course and in the next, Calculus 2, that I'm not going to just focus too much on this, but let's just take a look for now, and let's hopefully this gives us a good introduction to integrals. So let's find the antiderivative of f double prime theta equals sine theta plus cos theta, where f of 0 equals 3 and f prime 0 equals 4. Now this is a good problem. It's a nice tricky problem, and if you see something like this, it's important that you know how to solve it. Okay, you know the steps and you know exactly what to do, and you can just do it right away and not waste time in the exam. So let's start. So if you remember, the antiderivative is the reverse of the derivative, right? So if we remember, the derivative of sine, right, is equal to cos. So the antiderivative of cos is going to be equal to sine, okay? So what I like to do is I like to draw, just in the corner of my paper or whatever, you have sine x, cos x, negative sine x, negative cos x, okay? I like to draw those four out like that, all right? And if I have to take the antiderivative of the derivative of cos, or sine, I just go and I go down for derivatives and up for integrals or for antiderivatives, okay? So for example, if I'm on sine and I want to find the antiderivative, I'm going to go up, and so that's going to take me all the way back down to negative cos, okay? Similarly, if I'm on cos and I want to find the antiderivative of cos, I go up 1 to sine, okay? So if you're finding the antiderivative, go to this little list and go up 1 term, all right? And that's going to be the antiderivative, just for sine and cos. That's what it works for. Okay, so let's do that. So let's find the antiderivative of, and we're just going to do f single prime now, right? Because we took one of the primes away. This is the second derivative here, so we want to go back to the first derivative, right? So the antiderivative of sine, okay, is negative cos, and the antiderivative of cos is sine, positive, okay? And we can't forget our plus c. Okay, so that's the first part of our question done, right? And as you can see, we're also given a little bit of information here, okay? So if we take a look at this, okay, we see that f prime of 0 is equal to 4, okay? So when theta equals 0, then f prime of theta equals 4, right? And we can use that information to solve for this constant of integration that we added. If you look back to the last video, you'll see that we had to add a plus c every time we solve for an antiderivative. So, with that being said, let's go ahead and apply the information that we're given in the problem and solve for c. So, let's go ahead and do that. So if we go ahead and plug this in, so we say that f prime 0, okay, equals, and if we go ahead and plug in 0 for cos, right? So cos of 0 is 1. We know that, right? So that's negative 1. Sine of 0 is 0. Okay, and plus c1. And that is equal to 4. So c1 is equal to 5. Perfect. Okay, so, and you might be asking, well, why did I put c1? Why is it sub 1? Because in questions like this, we may end up having more than one c, okay? Because as you can see, it's the second derivative. So if we have to take the antiderivative twice, we need to add 2 c's, okay? So it's not a big deal. You don't necessarily have to do it, but I like to stay organized like that, okay? And it does help in certain questions. So we found out what c is, okay? And let's go ahead and continue along with the problem, and we will find and let's actually plug this in here and rewrite it. So f prime theta is equal to, okay, negative cos theta plus sine theta plus 5. And let's go ahead and we'll take the antiderivative of this function here, all right? And that will help us solve the problem. So we have f theta, all right? And f theta is equal to, and let's now take the antiderivative of each term. Antiderivative of negative cos, okay, is negative sine, all right? Using our trusty little chart here. The antiderivative of sine x is, we'll come back down to the bottom, negative cos theta. And for a constant, we're just going to add the variable to it, okay? So 5 theta. Perfect. And let's not forget our constant of integration. I'm going to call this one C2. All right? And that's where you see the sub C coming into play. So let's move up back up to the top. And we'll do exactly the same thing that we did with the information that's given, but now for f theta. Okay, so when theta is 0, f theta is equal to 3. So let's go ahead and fill that in. So 3 is equal to, and sine of 0 is 0. Cos 0 is 1. Okay, and 5 theta 0, so that's just 0. And plus C2. Perfect. So if we solve for C2, it's going to be equal to 4. Perfect. And if we go ahead and we plug that 4 into this equation, all right, we should have our final answer, which is going to be negative sine theta minus cos theta plus 5 theta plus 4. All right. So that question was exactly the same as, for example, if we weren't given this information, we would just leave it in this form, okay? We would just leave the C's unknown, all right? But since we're given this information, we can actually solve for what C is, okay? And as a result of that, we can write the question a little bit differently, but it's still the same process if we weren't given that information. So let's move on to the second one. So the second question I've selected is a little bit quicker than that one. And let's just take a look, all right? So we have h theta of theta is equal to 2 sine theta minus secant squared theta. And all I want us to concentrate on here is the rules of antiderivatives, okay? So the first one, we're not going to waste too much time with that. So we can say that h, so big H theta is equal to, and we just did that in the last question, antiderivative of sine is negative cos, so negative 2 cos theta. Now we have something here, all right, that's a little bit different that we haven't seen yet. And let's take a look at that. So what's the derivative of tan? All right, the derivative of tan theta is equal to, if you remember, secant squared theta, right? So that means that the antiderivative of secant squared theta is just tan theta, okay? And that's something that you're just gonna have to remember. Unfortunately, guys, you're just gonna have to memorize that. There's no way around it. All right, and that is our antiderivative. So that one was easy, but I just wanted to show you an additional rule. All right, so that's it for that. We'll end our antiderivative section here, but we will get into many, many, many more of these rules when we get into integrals, which is actually fairly soon in this course. So thanks for watching, guys. Stay tuned, like and subscribe if you enjoyed it.